Hello, let's start our webinar. It's about Erwin Hauer. Erwin Hauer was an architect who was born in Austria. He moved then to United States. He was famous, let's say, pioneer. He was one of the earliest, I guess, of modular constructivism. So he was famous for this kind of structures, like what you can see on the screen right now. They seem really complex and they mesmerize you with its fluidity. All of them, like they have these curvatures, beautiful systems, really beautiful. And even though they have this three-dimensionality and they seem to be quite complicated, it's a periodic pattern. Our webinar about Erwin Hauer. Erwin Hauer was an architect from Austria. Then he moved to United States and worked there. He is famous for his modular constructivism. So he's famous for this kind of constructions made of blocks. And even though they seem quite complicated, yes, but anyway, it's a periodic pattern that repeats itself. And so it means that what we can do is that it's a complex geometry that actually it's repeating itself. So the most interesting thing here is actually to understand what is the original module. So here's a really cool photo that I found of like from the studio where they made like prototypes. So he was, as you can see, this is all like three-dimensional patterns, like it's not your regular like panel. And they have this kind of like a play with profundity, with the depth. And in reality, even though they look quite complex by itself, the modular by itself is pretty easy. So it's just one shape that actually is pretty, like it's not that hard, I mean. So this one, for example, this module here is the one that he used to create this one, because the actual module is this. So it repeats in space like this. Okay, I got a little bit ahead of the guy, but okay. So, and it makes this effect here. So today I will show you like quite an easy way to reproduce this type of the thing. Even though, let's say, like there are many things that you can do, like you can completely make it parametrical. So you can make it that also the pattern inside is parameterized. Today, like we don't have that much time because we will be talking about like 1 hour, 1 hour and a half. So I will show you, let's say, like an easy way to do it and also pretty fun one. And if you have also, like, if you have basic skills of Grasshopper, you can do it. But like I expect that you already know how to move in the Grasshopper, how to put on comments, what are the panels like, so that you know to move around. So we will, first of all, in case, by the way, if you will be interested in some other things that Erwin Hauer did, because he made also like sculptures, many interesting thing which is based on like mathematics. There is his website of his studio. If I will be able to open it, we will see it. So today we will be working on these ones here, and here you can see all this kind of patterns. So today we will be working on design number 3, and if we have time, design number 1, because this one will be pretty easy. I will show you just the basic workflow here. And then just because this one requires a little bit more modeling, like we will see if we are on time. So let's start. Okay, let me just close this. We don't need it anymore. So of course, open Rhino and Grasshopper if you're following. So idea is that we will be able to put this pattern on maybe a curved surface. So let's start with the creating a curved surface. I will use a curve interpolate points to create one side. And I will just do like a wavy thing. With Alt clicked, I'm gonna click on the blue arrow and I will just write a value so it will make me a copy of my line. And then I'm gonna use the gumball and the scale of like the green square, and I will just slightly turn it. And then maybe I will slightly change it so that it gives us a little bit different feeling. No, this is ugly. Okay, like this. So, and let's just loft it. Okay. Okay, let me just flip it. Okay, so here we are. So we will start with doing this one here, as I said, just because the modular is easier. Where is it? Here, this one. So this one basically is one strip on the bottom and one strip on the top part. And then they repeat itself, and the point where they connect, they create this kind of shape of a cross. So in this webinar, we're gonna use, like, I saw that many people do it differently. So today we will be working with meshes, because meshes, since we're gonna make a pattern that will be consisted of many modulars, yes. The meshes, when you apply, they're a lot less consuming. And then you can also get this kind of like really soft shapes with the meshes by subdivision. I will show you today how to do it. So you can part from a really simple basic shape made of polygons. Then we're gonna transfer it to the mesh. And then after the wall is done, we're gonna do a subdivision. So in order to do that stripes there, I'm gonna start with a simple square. The square can have whatever size that you want. And I'm gonna start with a simple polygon here, like this, going to the middle. And then what I'm gonna do is I'm gonna make a planar surface. And by selecting, by clicking Command or Alt Shift if you're on the window, I can just choose one point. Okay, now wait, I need to, so I will copy this one for a moment. So So I'm gonna choose my vertex and just move it here. I think here it is. And then I'm gonna just extrude it here. I know it looks strange, but it will look fine. Maybe I will just make the lines. Okay, maybe we will just do it from the lines. So basically what we are trying to shape is something like this. Like basically this is what we are trying to do. So I'm gonna do a diagonal line to do it. And then here it is. Then I'm gonna put here point whenever I want to. And make the line like this. Then I'm gonna mirror it. And then mirror it again. So since we are working with the meshes, the important thing is that all of the polygons that you use, they have to have 4 edges. It can be only 4 in order for it to work well. Sometimes you also do 3, so there is trigonal meshes and there is quad meshes. Yeah, I suggest you, at least in the start, just to do quad meshes. So, and now we just need to do one here mesh. So I'm gonna use polyline. Here it is, here it is. So I'm making a closed surface and then I'm making planar surface. Then I'm going to mirror it like this and like this. Then I'm just going to unite all of them, and with the Control Shift I'm gonna choose these edges here, and with the gumball I just put them up like this here. So we got something. I will just flip it. And then I just need the same thing, but like mirrored. So I'm gonna do mirror. Here it is, perspective. And then I'm going to rotate it to 90 degrees. And here we are. Basically this will be our module. And when I'm gonna copy it, you will see what happens. It creates this kind of thing. Okay, now you see it's strange because probably I should flip it all. Here it is. So it creates this kind of geometry that exactly look like a simplified version of this. Okay. Now we need to apply it to our surface. So I'm going to Grasshopper. New document. Okay, since I used like I basically made surfaces, I need to convert them into meshes. So I'm gonna select both of these elements here, and I double click and I write brep because it's brep. And then I need to transform it into the mesh. Set multiple breps so that both of them gets inside of the same. So, And for this, there is this instrument that is called simple mesh, because in this case, I want us to have the most simplest geometry possible, because since I designed it in this way, that it has 4 edges all the time, I can just tell him to follow the most basic structure. So when you go to the mesh, to the util panel, you can choose this instrument that is called simple berep if it clicks. If it clicks. Why? Okay, I will just type it, but in case you know that it's in util. So simple mesh. And I connect the berep to the mesh, and here it is. So this is really good for when you have a simple, really something simple. And the only thing that you have to have in the mind that it has to be only 4 edges. And when I'm gonna to use Weavebird, there is this instrument that is called sub-D. As we know from Rhino 7, we have sub-D already integrated into the official version of the Rhino. But sub-D in reality existed many years before, because it's a mathematical formula of tessellation of the mesh. So basically what does the sub-D? It subdivides your mesh, all the edges getting twice more points. That's why they get more curvatured. So if you go to the Weavebird, one of the plugins that I sent you to email yesterday, they have all of this panel sub-D, where you can do different subdivisions. And for the quad mesh, in order to smooth it out, you should use Weavebird Catmull-Clark subdivision. It's the one that is used with the sub-D faces. So I will put it here. So I just want to show you what will happen with your geometry after. It will start to smooth out. So you can get like super smooth shapes with almost no time. In this case, I have smoothing also of the naked edges. If I would put the corner fixed, it would look more like this. So you can use a really simple geometry in order to arrive to a really smooth one after. So I will delete it because we don't need it for now. We will use it later. And we're gonna use this technique of paneling when you subdivide your surface or you subdivide your mesh into the quad panels, and then each quad panel will be like a box container. So in this case here, I'm having a surface. So what we can use is, for example, we can go to the pufferfish. Okay, pufferfish, where is it? Okay, so pufferfish is a plugin that I also ask you to install. So it's just because it has a really fast tools in order to make transform boxes like in a minute, so that you don't need to suffer. So if you go to the surface, we will use the one that is not here, because it will be in the twisted box. Yes. So here we will use the one which is surface twisted box through. We just need on one surface. Twisted box surface. It's the simplest one. So this one just takes your surface that we obviously need to put into Rhino. So we double click, we write surface. Here we have the container for the surfaces, and we click and we put set one surface. We connect it to the surface thing. Then it asks us for the thickness. Basically, it's the thickness, how profound you want your pattern to be. So you just do a slider, double click, and you write from 0 to 2 to 100. We will see in the future what will work best. Okay, in this case, okay, yes. Let me just hide it. Okay, in this case, by the standard, he makes you 2 boxes. I need just one, so I need to change my parameters. So here, he will ask me division parameters along surface U domain and V domain. So basically this is how many boxes you want into this direction and how many boxes you want into that direction. So you, in order to do it, you put range component, and then with the number of steps, where steps will be the amount of box that you want to put, think. Here, by default, you have domain from 0 to 1. So the range will be all of these numbers from 0 to 1. And if I connect it to you, you will see it will change me the number of boxes. So I'm just gonna Ctrl+C, Ctrl+V. Here it is. And then you can just put the amount of boxes that you want. Think. Here I have 2 boxes because here he is by default making 2, but I need just 1. So I will Ctrl+C, Ctrl+V. And I will put here 1. If you put 0, nothing works, so don't put 0. Okay, so we have boxes. Okay, and now what we got here is the twisted box. I have kind of too thick maybe, so let me just make it smaller. And then we're gonna use the tool from the transform toolbar. And we will use the instruments from the morph column. And we're gonna use the one that is called box morph. It requires a target, so basically this is the boxes that I want to map this one. As you have seen, I already made it into the box shape, so this is useful. So I put it here. Then the geometry is the one that I put here, and the reference, he's asking me for the reference box. So basically, what is the box that contains this geometry? In order to do it, you just can use the primitive container box, bouncing box. Here we are. And you just connect it here. But even though you will see 2 boxes actually here. I don't know if it's noticeable on the screen, but if I put on the panel here, you will see box 0, box 1. We need just 1 box for all of the geometry. So in order to do it, I need here to click right and click union box. And then we put it into the reference. And here we are. But as you have seen, something strange is going on. He just put only 1 element. Why is that? It's because the way how Grasshopper works, when you do this kind of the type of the thing, if you have more than 1 component that you want to move inside, you have to do group. So you just put group. And you put it into geometry. And here we are. Pretty. So let's do preview. And now when we move around, we get different density of the pattern. Yeah. So kind of cool. And the great thing about it is that if, for example, I want to change my pattern, like I decided that the opening is too small. Oh no, I wasn't supposed to choose it here. on the top. And I will just use the scale. Here it is. You will see that everything here updated as well. Okay, great. So now we wanted to smooth out. We got our basic geometry, it's there. So let's just go ahead and smooth it. But before we do it, we do ungroup. Ungroup, here it is. And then we will have all of these groups here. So basically, if I call on param viewer, if you don't know what it is, it's basically a tool that helps you to see your data tree. So we will have like a bunch of groups and all of them have these two elements here. So here it is. So if you see the tree, like a lot of lines. But in order to smooth it out in the right way, I cannot just smooth out this, because let me show you, and also I should save, you know, because with my computer, as we understood, save is important. Okay. So let's say I will do the subd thing right now. It will not look pretty. Here. This is not what we wanted, because we have all of these holes, even though, like, you know, it could be an idea also, it's not that bad, but it's not what I wanted. So it's because it happens because he is doing on each separate mesh subdivision. So in order to, I need just one united mesh for this now. So in order to do it, I'm gonna flatten the list. Here. And then it's many meshes. It's 300 meshes right now. So what I need to do is I need to join the mesh and then I need to weld it. So what we're gonna do, we go to mesh, util, and we're gonna need to choose mesh join here. And we connect our tree to mesh joint. So, okay, joined. But now we need also to weld it, so that it's all clean, because sometimes we need to align vertices, we need to clean it, because sometimes when you unite the mesh like this, yeah, you have some points that overlap. Like, for example, where I have the lines. Like, for example, here, in reality, it's 5 different points from 5 different meshes. Sometimes your program will do a good job by aligning vertices by itself, but mostly of the time, no. So I suggest you to use this component from the Kangaroo. So Kangaroo is we made another webinar about Kangaroo, but basically it's a physical simulation, and it has some really great components sometimes that you can use also outside of the physical simulation. And there is this one that is called Combine and Clean Mesh. So basically, instead of writing like align the vertices, all of these comments, you just connect this one and he will make you already a nice, clean, cute mesh here. Here. Here it is. And then here on this one, we can start to subdivide. This is where shit gets pretty. So. Also, it still makes mistakes. So let's do also, we probably need to align it anyway. So you go to Util and we choose the align vertices. Sometimes it happens because, for example, in my document here, I have the tolerance of 0.001. So it's a really high tolerance that you usually never need, but I have it. So I'm gonna connect my mesh to the clean mesh, and probably it's gonna, here in the tolerance, I'm gonna put 0.1. So all of the vertices that are in the radius of 0.1, they will get smashed together, that they will pull and it will become just one point. So let's try this and see how it works. And it works. No, it doesn't. Let me see what happens here. Preview off, preview off. Let's see. Okay, so he is having problem with aligning these babies. So I'm just gonna put a bigger threshold. So 0.5 to 10, and we will see if it will work. Echo. Yeah, now it worked. So in case if you have the same mistake, the same problem as me, so sometimes it works, sometimes it's not. Let's see. So echo. So let me just see for a second, because maybe the problem is my module. So the thing is that this has to be on the same let's say panel. So I will just choose all of my edges outside and see if they merge. Let's see. Okay, no, they align perfectly. So let's just do like this. I'm gonna do this and let me just make it slightly flatter, maybe it will be easier for him. Like this. Okay. So, and I will also make some align vertices. And what we should do, we also should flip it. So we will use unify mesh to unify the normals, because it could be also about the unifying them. Here I will still put like 0.2, it should be enough for the tolerance. And then I'm gonna use clean and combine so that it will weld it all together. And now maybe if I'm lucky enough, it's gonna work. But we will see. Ah, okay, here. So I choose to not to smooth out, so fix, so or at least make the corner fixed so that they meet at the corner, and then it should work. And as the level of deep vision, you can go up to 3. I don't suggest you to do it because the 3 will take you a lot of computational forces, but up to this, it looks nice. So the problem that we were having was up to these smooth naked edges. So here put corner fixed or smooth here. So here it is. What else could we do, for example? We could make it for example, that it changes its white, yeah? So for example, like what you could do is that you could do, for example, that one module is bigger, like that the spacing is bigger, and then one module has less spacing. So in order to do it, we do Ctrl C, Ctrl V of these ones here. And basically, let's say I want to have an attractor point like somewhere here. And let's say I want to have more holes in the middle, more spacing in the middle. So in order to do it, we would have to change our module. So we would have to make like first model and the model where we wanted to arrive. So I choose, I need to choose my edge vertices here. So it might, if you're having problems with choosing stuff, if you go to Subdi Tools, into the filter here, Subdi, here you can choose just to choose vertices, and it will allow you to choose the vertices only. So in case if you're having problem with Ctrl Shift, Alt Shift, like you can just make a filter on this. And I'm gonna make it a lot smaller. Like this. Maybe it's got too small, but okay, we will try. And but maybe I want this to be smaller also, because it seems to do too big space here. So let me just adjust it a little bit. In order, you see now I cannot move anything because I have filter on. So you just deselect the filter and then you can delete it. Okay, I will turn off my component here and disable it so that it doesn't update every time when I update my module. So I think what I'm gonna do, I will just quickly adjust it. So I'm gonna just to explode it, and I will just move this a little bit like this, and then I'm just gonna mirror it. I suggest you to have project activated so that it's easier for you to move things around and that you don't get it rotated in a strange manner. Here it is. Okay. Okay. And then I'm gonna do the same thing that I did here, and I'm gonna mirror it. Of course you could code this, like everything of this could be coded. It's just that it will take us, in this webinar, it would take us more time. Also, like you could calculate this on your panel, for example. There are many things to do it. I'm just showing you one of the easiest ways. Okay, and I will make this larger here. Okay, and then I'm gonna make Alt and copy it. then this one, I'm gonna make it smaller with the scale. Okay, and then this, I'm gonna move it up. Okay. And now, in order to make the transition from one mesh to another, I'm gonna calculate all of the transitions between them. So basically, like, this is really useful also, for example, in architecture, because like in Grasshopper, usually, like, we make these things that change constantly, like they change. You have 1 million variations, yes, but usually in architecture, like, you cannot do every module different from each other. You have to have like 6 modules, 7 modules, 10 modules if your project has a big budget. So like, you cannot do all of these transformations like this if it's not like a 3D printed project. Like, you have to have a final number of the modules that you can use in your project. So in order to do it, since all of the modules that we use here, they have the same number of edges, the same number of vertices, the same number of everything, we can just make twinning of the shape. So I will add this here, think, set multiple berep. And then I will do the same, Ctrl+C, Ctrl+V, with the now one. Then I'm gonna use join mesh again, and maybe clean and combine mesh also. So I'm gonna combine and clean. Also combine and clean here. So let me just turn off my here. Okay, seems quite cool. They seems to be pretty clean. And now we're gonna use the pufferfish instrument here. And we're gonna use something what is called twin to meshes. So basically you have mesh A, mesh B, and then you need to add a factor. He says to me, okay, here he says that they're different. So let me just I'm gonna redo this because probably when I made the mesh, probably something didn't move into the mesh well, so okay, here we have a problem because this one should be welded. So let me draw a line. So mesh, align, echo, result. Let me see how it looks. So okay, so that's the problem here, because as you can see, everything is welded except this one. So what we can do, we can go to mesh repair tools and do, let's see if the mesh will work. Okay, maybe we can do join edge. No, here it doesn't work. Okay, let's use, we will see, weld, angle tolerance. Okay, I think I will just... Che palle, sì. So, let's see, collapse. We should do... Select, okay, so I'm doing align vertices here and I'm just gonna choose my vertices. Okay, no. Here, here. Ecco, here it is. This one worked, good. So let me delete these ones that didn't work. I'm gonna explode it so that I can delete this one. And this mesh that is already clean, thank God, we will do the mirror. And then rotate it. So now, as you can see, all of the lines are the same, all of the vertices are aligned, so everything is fine, everything works. So, and now I will use this one as my next module here. And I will just scale it so that I get this kind of shape. Okay, now they will have absolutely the same typology because I use the same, basically that's the way, the better that you should do that. You make one mesh, it works fine, and then you change it. So the only thing that you can do is like move around the edges and move around the vertices. So since I already cleaned my mesh, I don't need this. Mesh, set multiple meshes, and then I will use clean and combine. Here it will be my mesh number 1. And here I will put my another mesh. So hot today in Milan, I'm dying. Join, let's see, 1 second. So he's just transforming one. Okay, let's see, like this. Okay, so let's do it like that. So I'm gonna choose these ones on the top. Okay. Here. Let's see if it works. Okay, it works. So here he made it. And then we're gonna do the same thing for the bottom ones, since he cannot do it. And now I'm doing the same thing for the bottom part. And for the bottom part here. So here it is. The factor depends on the range, so it's the same thing as here. We just create a range. We create number of steps, so for example 20. And then we add it here, here, And so just give them enough space so that they can breathe. So basically what it does, it's tweening from one shape to another. The more dramatical you make the shape difference, the more it can be perceived, let's say. So let me just make Ecco. So I think now it's pretty obvious. So here this is going from 1 to this. Perfect. So let's say we want 6 modules here. Okay, 6. And now we have 2 different groups of the meshes, here and here, and we need to combine them because I want this to be in one group. So in order to do it, we do merge. We connect the tween and tween here, and then we do the grafting, so that you're gonna get them by couples. So if, for example, I'm gonna bang the tree and see what's inside, you will see that now in each groups I have my top mesh and my bottom mesh. So let me just connect the mesh to here, and here it is here. So all of them are in their little groups and we can use them as our modules. Okay, here we have them. And now basically we need to put them here. So we made already twisted boxes here, but now we need to sort them to what is the closest to the point, yeah? So in order to do this, I'm gonna use area. No, sorry, volume, because we need volume. So volume. And I'm gonna okay, why? Volume properties could not be solved. So let's see, box. And let's connect this to this echo. So in case if you had the same problem, just connect the box container, because before he was thinking that it's not a geometry but it's a twisted box, because these are 2 different types of the data in Grasshopper. So just put a box, convert them to boxes, and then you're gonna get all of your points. And then we're gonna use pull point. And I'm gonna pull the points from the centroid to my point here that I made as my attractor. And I'm gonna do set one point and connect it to the geometry. So here we are, we have all of the distances. So basically we want their bigger distance, like, so this, the closer they're to the point. So if the distance is smaller, we want to put these are the most opened version. No, this one. So what we're gonna do is that we're gonna divide our tree into 6 parts, so that each part will be like the group where you put certain modules. So in order to do it, we are gonna do a sorting of these boxes, because if you see them right now, list item, you will see that they're sorted right now by X and Y, so it's like this by the rows. So, but I want them to be sorted, so I want to be like first the boxes that are around this point, then the boxes around that, yeah? So, in order to do it, I'm gonna use sort component, sort the list, and I'm gonna sort my boxes here by the distances that I found here. Okay, sorry. Keys to the distances and values A to the box. Okay, so here we are. we have our boxes, and if I'm gonna do list item right now, list item, so here we are, we have our box that is closest to the point finally. So, and so all of them, if you're gonna see right now, they're sorted in this way, they go around. So now we're gonna make a partition list because I want to divide my tree into 6 parts. So partition tree, partition list. So my list will be these boxes here. The size needs to be the size of the list length of this box divided by 6 because I want 6 groups of them. So list length, that will get divided by 6. I need my glasses. Oh, much better. I can see things now. Okay. And if you're gonna look to our tree, param viewer, param, 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 param. I promise we are almost done. So here we are. So he divided it like we have around 33 in each box. And now I'm gonna make out of this. So here I needed 6 groups, so I need to make steps -1. Okay. So now I will group. I need to group them individually. So ecco. So we got 6 groups now. And now we're gonna do this thing here, but the target we will connect to our box here and our geometry to here, and container we will connect also to the groups here. Okay, now I suggest you to turn off the Weaver bird because it might take a little bit of the execution. And let's see what happened. I'm curious. Okay, I made it vice versa. So what I should have done, I can just reverse this and it should work. Let me see. Ah no, I should reverse, I should do, okay, 1 second. So I need to put this one, I need to change them places. So like this, this to this. And then we do enable here. Ecco, here it is. Of course, the more drastically you change your components between each other, the more drastic effect you're gonna get. So for example, so let's just make it like really far away from what intended Erwin, but I hope he forgets. So here you can see the model effect. Okay. And now we're gonna do the thing. We're gonna do our thing here. And let me make preview. Here, and let's try to disable this. Let's see what happens if I smooth out everything. No, it makes strange things, so corner fixed. So here it is. So I told you that maybe we will do the second part, but to be honest, there is no time to do it from the start, but just to show you how it could be done. So if you go to here, so basically here our module is how I showed in the presentation of our Erwin. It's this one here that you need actually to model, yeah? So you could actually done it from the same, the one that we did. The only difference that they need to connect right now. So basically you're gonna get more modules here. So if I would do it to NURBS, basically this one should get connect here and these two babies should connect here. So probably what I would do is to explode this one. Then okay, let me explode also this one. And then you kind of need to load this too. So that it creates something like this. Like on the shaping you would have to work. I mean, it's a little bit more difficult, of course, but let's just see quickly what it happens, because probably it will not exactly give us what we want because it would require some sculpting, let's say. But just to see. And probably here we need to separate this also. Well, okay, let's, anyway, in case if you want to do it later, you can do it. So I will just do it quickly. So you will have a module that is more like this. Where's my grasshopper? And so if you go back to this configuration here, so here and okay, twisted box, okay, target. Okay, when you do things like that, disable. So here, here, here. Like probably it will be not right now because I made it too fast. But let's just see what happens. Because I think probably this has to be separated. And geometry has to be this one. Well, he starts to do something, but it's still not there. Because as I told you, it has to be separated. So, oi. So he made something, but not exactly what we need. So if you will feel like trying, you can try to work on this one if you feel like doing extra homework. So try to do this, but in a triangular form. So try to work on the shape. Just watch the module there, and then you need to make this one without project. So it has to be something like this, and then on the bottom also, so that at the end they can merge together and weld together. So try to do this in order to get this part on here. So we did today the one that is not even here, the one that was this one, which is still pretty cool. And now from that one, you can actually derive to this one. If you try and if you will not manage to do it, let me know, like write me email and we can see. So that's all. Okay, so let me know if you have any questions, anything. Come on, somebody please speak.
Hey.
Hey, hi Diego.
Hi, good morning, Barbara. Well, I just have one question because
Mm-hmm.
during my short experience in Grasshopper, I have realized like there are many commands, but to be honest, there are some of them that I don't have any idea that they exist.
Mm-hmm.
So, for example, with all your working experience, I don't know if you have any kind of resources to start to practice and start to discover each of the commands, or I mean, which would be the best advice that you would give to someone that wants to eh, yeah, improve in Grasshopper regarding the knowledge about each command?
So to be honest, I understand your question, and yes, it's a true problem that Grasshopper has like 1,000 commands, of course. So like to be honest, when I started, I just started to look in all of the panels that are the standard panels, and I just started to look at each command, because when think. So I started with the basics one that, like for example, curve, and then I would see that. So I would see, for example, what is evaluate length, yeah? And then I would just start to try to read. So for example, evaluate a counter this. Like, of course, this is sometimes this explanation a little bit hard to understand. But if you start just to put inputs, like that's the only way on the practice, to be honest. So like you just start to take all of the commands and you start to explore them. Also, like what I would highly suggest, like, is the Grasshopper forum. So so this one here from McNeil. And like if you have problem with any comment, I suggest you just to write it here, and you will find like examples, you will find the things. Also, there is a website with the whole explanation of all of the icons. But to be honest, it's not so useful, because at the end it's the same thing as they write here. So just start from the panels and start to learn them step by step. Yes, of course, everything what helps is that to constantly do like different examples, try to do different things, like also on the internet make a lot of exercise, and try to use less plugins. Like less plugins you use, better for you, because most of the things already exist within the Grasshopper by itself. So you don't need most of the plugins that they're there. So like they're actually like 3, 4, 5 plugins that you need is like Weaverbird, because it's doing for you subdivision, Pufferfish, because it has some instruments that are just work faster, and maybe Lunchbox, and that's all. For other tools, most of them you don't need. So just start to learn all of the basics from going from panel to panel. That's the only way. I'm sorry. You're welcome. Okay, any more questions? Anything you would want to say? Couple minutes and I will let you go. Okay, I guess no questions anymore. So it was true pleasure to see you guys. If the code will be uploaded, I will let you know. I will. Don't worry, there will be know your names and anything. It will be just like my screen, and that's all. So maybe it will be uploaded to YouTube, and I know that. Thank you very much, Simone, for your comment. I hope you liked it. So I will put it probably on YouTube. The code, I don't know, maybe yes, maybe no. In case if you will try to do the harder version of the pattern, let me know. Show me your results. I would love to see them. So on this, have a great weekend. Thank you so much for spending this morning with me. I know that at the sunny Saturday, it's not actually like the best thing to do. So enjoy your weekend. Ciao, ciao. Oh, somebody writing. Let's see.
Thank you.
Thank you. Thank you, Simone.
Bye.
So thank you guys. Bye bye. Ciao, ciao.